Welcome back, AP Calculus AB. This is assignment number 9009. Last lesson was trigonometry review part 1, and we were dealing with sine, cosine, and tangent, and evaluating them and reviewing also the unit circle. So we're going to go back to that, using that to solve for the radians, to solve for an equation based on trigonometric functions. And when we take a look at our restriction, we only want answers from 0 to 2 pi, 0 included, but not 2 pi. Okay, so we're only going to restrict ourselves with that. Here are our reference angles again. Our angles again, one more time. Reference angles is over here, and then we have these angles in their respective quadrants. So again, this is quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. I made a couple of things to help you guys out last video, like to help you memorize, odds 1, 3, 5, 7, and then to remember the pi over 3 patterns. It was a sequence 1, 2, 3, 4, 5, and then this one over here at 5 p.m. I made a sentence. At 5 p.m. I went to 7-11 with the radians that deal with over 6. Okay, so we're going to use all of this. I'm going to also draw my special right triangles, the two of them, the 45, 45, 90, and the 30, 60, 90. So pi over 4, pi over 4. And then their ratios, their basic unit lengths are 1 square root of 2. This is going to help me out, especially when we do the other three, cosecant, secant, and cotangent. So this is pi over 6, or 30 degrees, pi over 3, or 60 degrees, and the ratio for that is 1, the hypotenuse is 2, square root of 3 by the 30 degrees, or pi over 6. Okay, so that's going to help us with that. All right, the homework problems are already embedded, so what I think I'm going to do is I'm going to do numbers 2, let me just mark that, 2, 5, and then number 11 on that one, and then I'm going to stop the video, and then I think there should just only be one more video on this. Okay, really when you look at number 2, you want to solve for the radian, so you want to get this by itself. I think what I would probably do is get rid of this fraction, multiply both sides by 3 over 1. So multiply both sides by negative 3 over 1, apologies. Okay, so those are going to go away, and then this 3 and this 3, those are going to undo each other. So now we have negative square root of 3 is equal to tangent of theta. Okay. So what you're really asking now is, without a calculator, you have to ask yourselves what radian or what angle makes tangent negative square root of 3. Okay. So what I usually do is I could probably, so let me go write that question down. So that's what we're trying to ask. What theta, so what radian or angle makes tangent negative square root of 3? Okay, so that's the question. So my steps for me is I usually go back and refer back to the special right triangles. And I want to see how I can create square root of 3 using our tangent ratio opposite over adjacent. Okay, so this is opposite over adjacent. TOA, SOHCAHTOA. TOA. So the only thing that we have square root of 3, so I'm not even going to look at this one because this does not have a square root of 3, but this does. So we need to have it so that tangent is equal to square root of 3. And I think the only possibility is if we have tangent of 60 degrees or pi over 3. Because if we take this as our target angle, then, and if we do opposite over adjacent, it will be square root of 3 over 1. Okay. If we use 30 degrees, it will be 1 over square root of 3, opposite over adjacent. So we're not going to use this one. We're going to do pi over 3. So we have 4 options for us. So I'll do number 2. We have 4 options. And the 4 options are going to be listed over here. So those are your 4 options because we had said it's pi over 3. So we got pi over 3, we got 2 pi over 3, we have 4 pi over 3, and then 5 pi over 3 as our options. This is where I also draw all students take calculus. All students take calculus. And I do want to remind you guys of how this works again one more time. The first quadrant, that means all sine, cosine, tangent are positive. Okay. On the second quadrant, only sine is positive. Third quadrant, only tangent is positive. And then over here, on the fourth quadrant, only cosine is positive. Okay. We have our 4 options, but look at our answer. Our answer is negative square root of 3. So we want to find values of radians that makes it negative and not positive. Okay. So that means that we already know that tangent is positive here on quadrant 3 and quadrant 1. So we're not going to choose those because we want a negative square root of 3. So since we've eliminated quadrant 1 and quadrant 3, we're also going to eliminate quadrant 1's answer, which is pi over 3, and quadrant 3's answer, which is 4 pi over 3. So you have 2 answers. So your radian is going to equal to 2 pi over 3 or 5 pi over 3. So you need to list both of those answers in order for it to get correct, because now you have 2 possibilities of getting negative square root of 3. It's either 2 pi over 3 or 5 pi over 3. You cannot get it with these because it's going to make positive square root of 3, which we don't want. Okay, so that's number 2, and so this is how it works. Let's go ahead and do number 5. Oh yeah, sheesh, my gosh. Okay, number 5. I mean, let's minus 5 on both sides first. Can we do? Yeah, let's do that first. Sheesh, gosh. Okay. Okay, I see. I think we're just going to have to change this into a fraction, and to change that into a fraction, it's going to be 10 over 2. All right, it kind of looked really intimidating from afar, but I think we can now put this in one fraction. 10 plus square root of 2 minus 10 over 2. Okay, now it's going to be less intimidating. Oh boy, sheesh, my gosh. Square root of 2 over 2. Okay, so the question is, we need to find a radian or angle that makes cosine square root of 2 over 2. So we have our theta options. Okay, so first off, square root of 2 over 2. I'm going to go back to my triangle. I'm probably not going to use this one because I don't see any square root of 2's, but I'm most likely are probably going to use this one over here. Okay, in order to make square root of 2 over 2, it's going to be 1 over square root of 2, okay? 1 over square root of 2, if you multiply by the radical on the denominator, that's square root of 2 over 2, okay? So we have options for ourselves. Our reference angle, our angle that we're going to look at is pi over 4, okay? And we have 4 options. We got pi over 4, and remember our pattern, 1, 3, 5, and 7, okay? We just got to figure out all students take calculus, okay? We want positive square root of 2 over 2. And we know that cosine is positive on quadrant 4 and also one more quadrant. Where is it? Also in quadrant 1. Because those are the only times when cosine is positive. So we're going to delete or not select the answers, the angles that are in quadrant 2 and quadrant 3. And those are these angles over here. So we're going to cross this out because that's in quadrant 2 and this one is in quadrant 3. So your final answer for number 5, your 2 possible is pi over 4 or 7 pi over 4 will be okay. All right, so just be careful. I know the patterns right now is like I'm having 2 answers. It really depends sometimes. Sometimes you'll have 1, sometimes you'll have 3, sometimes you'll have 4, sometimes you have none. It depends, and when we get to number 11, you'll see a little bit. So let's go to number 11 right now, and then I'm just going to stop the video. Okay. Oh yeah, I do want to make sure our answers. Yeah, our answers are within 0 and 2 pi. These are in between 0 and 2 pi. Okay. All right. 11, and then we'll move on to the last video, and I think that's it for this lesson, really. So number 11. Oh, we got a okay. Number 11, it kind of looks a little intimidating, But what I want to show in green first is an algebraic equivalent. So the algebraic equivalent is if we replace sine of theta with x's, because we have 2 sine squared of theta minus sine squared of theta minus 1. So the algebraic equivalent, and I'm just going to put this over here, is like 2x squared minus x minus 1. We can do this because we've already reviewed factoring this type of problem. So let's go ahead and factor, and I'm just going to give you the factoring mode, the factors, sorry. So 2x plus 1, I believe, and x minus 1. That should work. 2 times -1, -2, and then plus 1 will give us the -1. Okay, so that's our algebraic equivalent. What we're going to do is we're really just going to parallel this with your sine function. So if this is how to factor this, then your next step is going to be in factored mode like this. Now just replace your x's with sine of theta. So now this is going to be 2 sine of theta plus 1 and sine of theta minus 1. So you see how they're parallel. We're not saying x anymore. We're just saying sine of theta. We have a different input now. Okay. From here, we are going to do ZPP. 2 sine of theta plus 1 equals 0. Apologies for that. And then sine of theta minus 1 is equal to 0. And so we're going to have to solve these two one by one. Minus 1, minus 1. 2 sine of theta is equal to 1. So sine of theta is equal to -1/2. Okay. All right. So again, I'm going to go back to my reference angles, and I think I'm just going to have to do this equation on another because I don't have space. So let's go back to our reference angles that makes sine 1/2, and just ignoring the negative for right now. So let's take a look. I don't see like, it's probably not going to be pi over 4 because I don't see like a full 1 or 2, but I see 1 and 2 over here. Okay. So what makes sine 1/2 is, remember, sine is opposite over adjacent. And I think I can already see it. We're probably going to use pi over 6 because if we use this, opposite over adjacent, we're going to get the 1/2. Okay. So we have options for ourselves. We have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. At 5 p.m. I went to 7-11. I'm going to draw my all students take calculus, but we want it so that the theta makes it a -1/2. We already know sine is positive on these two quadrants, quadrant 1 and quadrant 2, but we don't want the positives, we want the negative values, so we're only going to take answers from quadrants 3 and 4. Okay, so that means we're going to cross off pi over 6 and 5 pi over 6. Okay, so we're going to keep these for a little bit, and yeah, so we're going to keep these two, and we'll circle it for our final answer a little bit later after we do this. Okay, let's add 1 on both sides. At 1. Sine of theta is equal to 1. I believe there's only one value for that, and I think that's going to be 90 degrees. If you put 90 degrees here, sine of 90 degrees is 1. So our theta is going to be pi over 2. So these are going to be your 3 answers. So like I said on the previous question, sometimes you might have 1, 2, 3, 4, just depending on the problem. Okay, so those 3 answers must be included on number 11. I'll see you guys on the last video.